Hi, I'm John Bissell, co-CEO and co-founder of Origin Materials. In this video, we're going to do our best to recreate what it's like to take a tour of our pilot facility here in West Sacramento, California. We want anyone interested in Origin to be able to see our process and facility no matter where they are in the world. My co-founder, Ryan Smith, and I met as chemical engineering students at the University of California, Davis. We founded this company in 2008 and spent over a decade developing a one-of-a-kind, disruptive technology that converts plant-based feedstocks like wood residues into a wide range of materials, including plastics. Our platform can be applied to making products in a range of end markets, including clothing, textiles, plastics, packaging, car parts, tires, carpeting, toys, and more. What's special is that our materials are carbon negative, cost competitive with petroleum-based products, and fully recyclable. We believe that today, we're at a tipping point when it comes to carbon. There's been a tidal wave of corporate net zero pledges, and we see our job as to help companies achieve their decarbonization goals by providing them with carbon negative materials. Our mission here at Origin is to enable the world's transition to sustainable materials, and our goal is to help drive that once-in-a-planet transition to net zero carbon as fast as possible. At present, we are scaling up our technology and building our first commercial scale plant in Sarnia, Ontario. But today, you're going to see our pilot operations in California. This is where we've developed our platform for turning the carbon found in non-food biomass into useful materials while capturing carbon in the process.
Hello, I'm John Birmingham, a lead process engineer here at Origin Materials. Today I'm going to provide a walkthrough of how we convert biomass into downstream products using our core platform chemistry. To kick off our tour of Origin's pilot facility, I'm going to start by showing you some of our feedstocks. For example, here's a wood residue. These are referred to as pins and fines, where these larger particles are the pins, and the smaller particles, closer in appearance to sawdust, are the fines. These wood residues are produced by sawmills or pulp and paper plants in the process of generating lumber or wood chips. Because of our unique technology, we can use the carbon in these wood residues or larger wood chips to make materials that would normally be made from petroleum sources. Wood residues like this are low-cost feedstocks, generally a few cents per pound, and a dramatically lower price volatility than oil. Biomass sources like wood chips are also readily available at scale. An Origin plant could fit neatly into existing supply chains by, for example, co-locating with an existing or recently decommissioned pulp mill. Our process chemistry is also versatile enough to accommodate a wide range of non-food related biomass options, which really sets us apart from other competing technologies. We've experimented with over 100 different feedstocks, including everything from wood and old cardboard, all the way to empty fruit bunches from palm oil processing. Now I'd like to walk you through our process of converting these feedstocks into products here in our pilot facility. We receive super sacks of woody biomass, which requires minimal processing. Our feedstocks are then transferred to our pilot plant stirred tank reactor. Note that the reactor at Origin 1, our first commercial plant, is exactly like this reactor here in the pilot, but about 50 times larger in volume. At the start of a batch reaction, we pump in the aqueous phase, then we load the biomass feedstock and our organic solvent into the reactor. Next, we spin up the agitation system, which blends the two liquid phases together. As an analogy, picture something like salad dressing, where there's two liquids, in that case oil and water, that you'd shake up to get a well-mixed system. At the pilot, while the mixing continues, we heat the reactor contents. Once we've reached the optimal temperature, we add hydrochloric acid, or HCl. And you can think about this like the chemical equivalent of a sledgehammer that breaks down the biomass feedstocks. As the reaction proceeds, we generate our products, CMF and HTC, where CMF is chloromethylfurfural and HTC is hydrothermal carbon. These are our major platform chemicals, which are produced in addition to smaller quantities of furfural and levulinic acid. Once the reaction is complete, we spin down the agitator, allowing the organic solvent to coalesce or separate from the aqueous phase. The organic solvent, containing the CMF product, is removed from the reactor for downstream purification, while HTC, a solid product, is then filtered out of the aqueous phase. This is done at the pilot using a filter press, and you can think of each plate in the filter press as operating like a cheesecloth strainer that traps the solids and allows the liquids to pass through and exit the press. The series of plates in the press generates solid cakes of HTC that can then be dropped down into collection bins as the press is unloaded by operators. This technology is easily scalable with our Origin 1 plant using a similar, larger filter press for the exact same application. HTC can also be further processed to optimize material properties. Origin and external industry partners have worked extensively together on HTC product development, with uses including as a solid fuel, as well as higher value applications like a bio-based replacement for fillers like carbon black in tires and foams. Let's go back now to our product CMF, chloramethylfurfural, which we extracted from the reactor with our organic solvent. We separate and purify CMF from the organic solvent via distillation, and we recover the solvent for reuse in our pilot reactor system. At our pilot facility, the purified CMF is then reacted with hydrogen gas in the presence of a heterogeneous reduction catalyst to produce dimethylfuran. Dimethylfuran is then purified and reacted with ethylene in a different solvent and catalyst system to produce paraxylene. Paraxylene is an important commodity chemical, normally derived from petroleum, and a primary precursor to the plastic PET, or polyethylene terephthalate. PET is used in packaging, automotive components, textiles and clothing, and many other applications. One of these bottles is made from petroleum-derived PET, and one of them is made from Origin-produced bio-based paraxylene converted to PET. They're exactly the same. Physically, chemically, we actually have to mark the bottoms of the bottles so I don't mix the two of them up. The real difference is that this bottle started as wood residues, while this bottle started as crude oil. We're thrilled to take this technology to the world. We've spent over a decade here bringing this from a concept to a reality, and now taking the next step in scaling to a commercial plant in Sarnia, Ontario, Canada.
Thanks for taking the tour. I hope it gave you a deeper understanding of our technology and process. I'm proud of what our team has accomplished here over the past 10 years plus at our pilot plant. We're able to take cheap, plentiful, renewable raw materials and create a variety of carbon-negative materials and products that support the world's transition to net zero. Our technology platform can supply new materials and molecularly identical replacements for many materials normally sourced from petroleum, but with the expected effect of removing greenhouse gases from the atmosphere rather than adding more. The carbon negative footprint of our materials is backed up by an ISO-compliant LCA authored by Deloitte, which can be found online at Origin's website. We've sent much of our product out to industry and academic partners for testing and development with favorable results. And so we're thrilled to commercialize our products and bring our carbon negative materials to a range of applications, including clothing, textiles, plastics, packaging, car parts, tires, carpeting, toys, and more. Thanks for spending some time with us today, and thanks for taking our pilot tour.